Okay, let's do it. So, bienvenue. Any guess where I'm from? So, my name is Nicolas. If you're searching for a clue, so there was one on my previous slide. You've got a sticker here. So, what do you think? France. Yes, indeed. So, I do have this outrageous French accent, I must admit. So, just want to say, please, if you do not understand me correctly, don't hesitate to ask. Really, it's going to be a technical talk, so I want to make sure I don't lose anybody. And the other thing you need to know about me today is that I do love SQL, just as I do love data and I do love Tableau. Well, before starting, I want to share a story with you. The story behind this dashboard, which is a dashboard I taken right from the field, a customer of mine. Yeah, I must have said I'm an SE at Tableau, so I'm working in Paris, helping customers with Tableau deployments, help them use our products. And so the point is, with this dashboard, while I was preparing this session, I was thinking of it because one day my customer called me and say, okay, Nicolas, we've made this beautiful dashboard. We've followed all the best practices on design that you gave us, but look, it's taking more than 30 seconds to load, and we don't know what's happening. So I've been there on site, sit with him, and indeed, I look at the design, and it was okay. No complex calculation behind. So after that, I looked deeper, and then I realized that 7 tables were joined behind with more than 500 million rows not in a very efficient way, to be honest. So what we've done is we actually denormalize the data. We've used materials views for the worksheet you see at the top and column store indexes. And we took the dashboard from 30 to 5. So the reason I share this story with you is because sometimes data architecture matters. The way your database objects are structured is important for Tableau performance. Does that sound right? Okay. So you're in the data architecture course. It's gonna be technical. I won't be offended if you leave. I think it's rather intended for people like data stewards, data engineers, DBAs. We're gonna dig into database concepts. But if you stay here, it's that you're ready. Okay? So our agenda for today, we're gonna understand Tableau VSQL to abstract and to SQL. Actually, the different steps before Tableau generates a SQL query. We're gonna look at the data access layer, what are the components and how we can play with. We're gonna set up database performance in Tableau, and finally we'll talk about Hyper and how it can help us to speed up data source. Okay? So, what is Tableau? It's a visual dynamic SQL generator, and that's the magic indeed. Tableau took drag and drop from our users, and turn it into VSQL, which is a sentence-like statement. With pairs and shaves, we've got sum of sales on rows, category on columns, region on filter, and then it turns it into an abstract query, which is an XML statement, much more verbose. And finally, it sends a query to the database. Okay? So how do we do that? Actually, we interact with the blank canvas. You know that. When you put fields on columns and on rows or max, it will add fields to the select clause of your query and the group by clause. And if you use pages or filters, it will put it in a where predicate. And also, there are some kinds of calculations, simple, just as above, and also table calculation, LODs, and pass-through SQL. And we're going to look at right now how what it means to Tableau and how it behaves. So let me just open my workbook. So to show you the queries, I'm going to use a tool which is called Tableau Log Viewer. Do you know Tableau Log Viewer? How many of you know already? Yeah, maybe? So it's you can download it on GitHub. It's completely free. And it helps you read Tableau logs. I don't know if you've already opened a desktop log file, but it's JSON and not really readable easily. So I'm going to open it here. And first of all, I'm going to look for my log file, which is lot.txt within the log folder in the Tableau repository. Sorry for the French here. And here I'm going to look for a key, because it's key value, just like JSON, which is QP batch summary. I'm going to look at that just to show you what I've said before, which is for this single sheet, this single view, you see it's quite simple, sum of sales per region. Here are the query Tableau generated. You can see here the query abstract, okay, the XML statement, and here you'll see the corresponding SQL. Okay, makes sense? So what I'm going to do now is I'm going to use another functionality of this Tableau Log Viewer. I'm going to click Event. I'm going to use Highlight, because I want to highlight and query. So basically, I'm saying TLV, just call on me the end query rows in yellow. And also, I can say, OK, just show me this highlighted rows. And I will put live mode, so it can capture what I will be doing within my workbook. I will just reduce it, so you can see both at the same time. You can see? It's OK? So first thing I'm going to do is I'm going to actually disaggregate my view. Don't know if you know that, but within the analysis menu, you can uncheck this box, aggregate measure, and basically what it will do is it will, instead of asking for a sum of sales here, it will ask for every sales and region that are in my table, so at the orders level. You can see here all those stars. That's the rows that are in my data. And if I want to look at the query, it's the simplest query ever. Okay, so let's go back to an aggregated version. And what I can do is I can add a filter on category. So I can just drag filter here and select furniture. And guess what? Now I've got a workload. Shows right here. So now let's do something more. Let's join things. I will just go to the data source. Now I will add the regions table. So when I look at it, I can see that I've got yes. Actually, I've got a reference of all the other IDs that are written. So I want to keep all my original rows from my other tables. So I'm going to go for a left join, just switching here. And now we can look at the query. Here you'll see the join. Okay, so far so good. So let's do a union now. So I've already prepared the data source. I'm going to show you. You can drag and drop tables here from here to there. So you can union tables. And in SQL, it will cause a union all, if you know SQL. And here you will see, so now I've got actually my from here. It's composed of two subqueries. The field that I have asked for the Americas table and the other one that I've asked for the APAC table. So now let's look at calculations. So simple calculations. Actually, there's two kinds of calculations, just like the disaggregate measure thing. You can have aggregate calculation, meaning that you're using aggregate function within it, sum in that case. And this actually will lead to this. Tableau will ask for the aggregations, and then will perform the division locally. I can also use a row calculation, which is different. I didn't use here any aggregate function. So basically, what I'm telling Tableau is, please perform this operation for every row. So keep that in mind. And what happens? So I ended with this pretty complex case when statement. Actually, what Tableau is doing is it catch the case, the eventuality of having a zero you can't divide. So this is what this case when is for. The first part here. Up, and then the division. Okay? So it's okay for the simple calc. Now let's look at something different. Let's say here I want to compare the country sales with the total sales for the furniture category. So I want for each row of my viz to have this total sales. It's a pretty simple, not really a deep advanced calculation, but we can look at it through different ways. We can use table calcs, we can use LODs, and we can use pass-through SQL, and that's what we're going to do. We're going to look at the three different things to do it. So with table calc, actually, what did I ask for? I asked for a window sum of sales. Okay, and you see the results are computed table across. It means that if I look at the compute using, here, it will take all the table. That's my partition. Okay? My window is all this. To get this info, I can also use an LOD. So I will fix the category, because remember, I want the total sales only for the furniture category. And I will ask for sum of sales. Now let's have a look. I should have shown you, sorry, the query. For the table calc, as you can see, the calculation is done by Tableau. So Tableau will send the query, and afterwards will locally perform the calculation with the table calcs. What happened with the LOD? Not this one. I think it should be the same anyway. That's what I want to say. So here's what happened. Actually, I ended up with nested SQL. Which is not the best way to treat that kind of issues, because what you need to know is that when you add lots and lots and lots of join, your database can mess up in finding the correct way to and the correct plan to get the data and to do the joins. So instead, I could have used a pass-through SQL, which is this. So I can call a row SQL function, which will be at the aggregate level. Now you know what it is, and which return a real. And what I will do is I will write my query here, select sum of sales from my orders table where category equals to furniture. I will use the person 1 and person 2 to reference the arguments here. And here you go. My NetSQL is now at the select level, and I don't need to join anymore. So you see, understanding how Tableau generates queries is important for you to have an impact on your database. Okay? So far, so good? Last but not least, the custom SQL. So now let's have a look at a more complex problem. Maybe some of you have already met. I want to look at the average number of days between two orders. That means that I need, for each order, to calculate the preceding order date for each customer. And I want to look at that in my viz at another level of detail, which is the country level of detail. Can I do that in TableCalcs? No. Because the TableCalcs, I will have to bring the level, order level to my viz. Can I do that with an LOD? maybe with a lot of LODs, because I will need for each preceding date to add another LODs, but I don't know how many I got in time. So, custom SQL seems to be a good way to do it, actually. So what I can do, you can add, instead of adding a table here in the data source page, you can write your own custom SQL. So always be aware of the fact that it will end it as a subquery. So you need to be aware of that, and especially of the number of columns you will get and you will ask your database to get. And here I've used this. This is what I think a great database feature, actually. It's Windows OLAP functions. I think it's SQLancy 2003. So you might have it in many of the databases. And you've got this great option which allow you to define small partitions and to create like this a last order date for each of my rows. And I can still join it with another table. So if we have a look at the query, we'll see here we've got my custom SQL, which is then left joined with my table, just as the way it was before. Okay, so let's switch back here. Now let's talk a bit about the data server, because we just saw how Tableau generates SQL. But I would just want to share with you what happens with, when you use the data server. So first of all, the data server, it's a must when you shared metadata, also to centralize client drivers. Pretty sure you all knows that. But there is one caution. It's the fact that the Tableau server communication process complicates things. Let me show you. You remember this? So what happens with the Tableau data server is actually the abstract query, remember the verbose XML statement, will turn into a much more verbose XML statement, which is called a SQL proxy statement. And then the Tableau server process will convert it into a SQL physical statement. You keep that in mind when dealing with the data server. So another component of the data access layer, when I say the data access layer, is the object you can leverage between Tableau and your tables. It's the database views. So database views are great, and I think they're great for working also in addition to the data server. Because the SQL defined in the view is transparent to Tableau. Basically, Tableau treats database views just like tables, so generate sequence against them. And then it's the database which turn it into an efficient SQL. Also, database views can cover a lot of use cases. Access control, row, column level security, business rules, and semantic. And the best thing is that you can aggregate views. So you can materialize, you can persist, aggregate to speed up performance. You know that. So this morning, you just saw we announced new data modeling capabilities. Are you excited about that? Great. So what's coming? It's actually, at the top, you can see the way Tableau behave today. You've got You define your Tableau data source. You just join table, which is the way I did. And when you do your viz, you fire your query, Tableau will denormalize the data, actually. If you remember what Tyler done this morning, he just used population of California, and the duplicated rows, due to the fact that it was denormalized in this big table, leads to 7 billion people in California, I guess. That's a lot. So what's happened is, I don't know if it's, and I'm curious if it already happens to you. What happens is that people use LODs, so those nested SQL statements, to renormalize. That's the end of the schema. And we've just seen that it's not performant. So what the new data model will change is that now it will, depending on the viz, it will point out to the correct level and to the correct tables. Also, it will be, there's a lot of upcoming new things with that, like auto joins definitions. So before digging into database performance, is data architecture the magic bullet? No. Please keep in mind, if you're dealing with performance troubleshooting with Tableau, the first thing to look for is workbook design. Then you'll go to calculations, are they efficient? A lot of case when or embedded calculations. And after that, you will look to the queries, just like we've done, and the database. So to understand database performance, we've got to understand what's the life cycle of a query. When you fire a query to your database, it's parsed by a parser, and then it is sent to an optimizer. And what the optimizer will do, it will try to build plans to collect your data, treat them, and access them, and join them, blend them the way you want to. And then it will optimize, meaning it will pick up the best plan to do it. And finally, it will execute the query. And all we're going to see next is actually linked to what can we do to let the optimizers pick up the best plan quickly. We can use database objects like index. So index a copy of a selected column from a table. They are used to quickly locate data without having to search for every row in the table. And it can have tree structures like B plus trees, B minus trees, but also hash tables. There's a lot of different index structures. Another technique which is linked to Tableau that we can use is John culling. You know John culling. It's a great technique which is actually, you can, if the referential integrity of your data is guaranteed. What does that mean? It does mean that if I join the table A with a table B, I want to make sure that every column that are in every join condition columns are present in table A and also in table B. I don't want my join to filter rows, okay? If that is the case, you can tell Tableau to assume referential integrity. So what happens is that here I've got two tables, the line item tables and the other tables. And you see the join results tables. And imagine I am asking for the total sales amount. I only need to look at the line item table because the answer will be the same if I perform the join. So if I know I've got every primary key, and foreign key, so the join key, are present in both tables, I don't need actually to perform the join. So I can tell Tableau that. We're going to see it in the demo just right after. The partition pruning. What is partition pruning? Partition pruning is actually you can, when you create a table, you can partition your tables. You will see it in Tableau as a single table, but physically, it will be stored in multiple partitions. And if you use the partition key in Tableau, for instance, as a filter, it will dramatically speed up performance because it will avoid scanning the full table. Let's go deeper in the database, the way the data is stored. Traditionally, data is stored in rows, but you can also choose to store it in column. That's what we call column stores. You find it in most of the databases. This is very well suited for OLAP-like workloads, just like Tableau workloads actually, meaning queries that make sums and group bys. Also, you can compress really higher because all your data is stored in a sequential way. So let's have a look at this star. This is the star we're going to use for the demo. So I will have another tables, which is on my laptop, on a database, SQL Server database. 40 million rows, which is not a lot, but the concept we're going to see apply at scales. And those 5 dimension table: customer, product, employee, and market. Let's go. So, this is the non-optimizable structure. So actually, behind every of my red sheet, you will have different data sources. Okay, you will see at the left. So it's long, huh? Isn't it? Okay. So it will always be the same query. We can have a look after. Actually, it will always be the same rows and columns and filters here. So what I'm going to do here is I'm going to turn on the performance recording. You know the performance recording or not? That's very useful. Actually, you can turn that on, and it will gather all the data about the event that Tableau will send and the time it's spent where. So let's do it. I'm going to start it. And now I'm going to go for the same, really exactly the same database, but with assumed referential integrity. So what it is, the only difference between those two data sources here is that here this option is not checked, whereas here the option is checked. You see? And yet, it's slow. Five seconds more. By the way, I should have shown you the data source, which is just the star we talk about. Okay? Simple star. Now let's put an index. We saw what it is on the filter columns and the join columns. Should speed up a bit. Now let's partition our table. Again, the exact same column, rows, and filters, fields on my view. Oh, faster. So the table is partitioned by order date. So it's used here on my filter. The column store. Now we took the order table and we changed the way it is physically stored. Not anymore in rows, meaning that my database won't have to scan all the data to only get customer state and sales total. Actually, it will only scan the column it needs. And let's do the exact same thing with Hyper. Okay, now we can turn off the performance recording. And have a look. So here you see my worksheets. For those who don't know, the performance record is composed of 3 views: timeline view, events sorted by time, so the longest events, and the query at the back. Referential integrity. So here I can see that indeed I activated join culling. So Tableau didn't do the joins. That's fine. That's why I asked him. But yet it's slow. 20 seconds. When I've added an index, so now the SQL is different. You can have a look at it. You can see here all the joins are performed. But yet, it's still 15 seconds. The partition, the exact same query, and 11. And now the column store. Less than a second. We don't even see Hyper here. Actually, to see Hyper, we'll have to filter the events that are like below 0.10 seconds. And we'll need to, let's have a look at this view. And let's look at the worksheet. Hyper is here. That's fast. Really fast. So the thing is here, you can mix. You don't have to choose between partitioning or indexing or column store. The best way to do it is to use all of this. If you've got a billion rows table, actually, and you will fire this kind of workloads, all-up workloads, it might be a good idea to use a column store format. Within SQL Server, it's called column store index, but you find it in the big data world. It's called .parquet or .orc. It's the file format which are stored in column. And maybe you want to store them in column and also partition them because you know you will only access. You only need a few time scale or I don't know. So Hyper. So far we've seen databases, but what happens if you've got a denormalized or flat object or NoSQL or JSON or I don't know, and you want to speed up? Use Hyper. Hyper is great. It's really a great technology and it can help you really save a lot of time. Why? Why is Hyper so fast? There's 4 pillars around Hyper. The first one is it's a main memory system. It means that everything happens in memory. It's CPU optimized. That means that every query is split into small unit tasks which are performed in parallel at the CPU level. And Hyper does that very well. Another breakthrough with Hyper is the fact that Hyper doesn't interpret queries. It compiles them at a low-level language. And finally, it's very good at doing optimizations. And we've got this new feature, Normalized Extract, which is coming in 2018.3. I'm curious, how many of you have had to set up a user security table for doing rows level security? Yeah? You wanted to do it with extracts? Yeah. So you know what I mean. Because as we just saw, Tableau will denormalize data when you take an extract, meaning that it could lead to a Cartesian product. If a single user in user security has access to many records, imagine. So now we've got this option to create multiple tables within Hyper, meaning that in a single extract, you will have multiple tables, and you only join them at query time. Federated Joins. Also a great feature, cross-database joins. You know how it works? Pretty simple. Tableau query every row-level data, bring into Tableau, and perform the join locally. But what happens if one of those tables is big? Cross-database joins move a lot of data around, and it's really something you've got to keep in mind when you use cross-database joins, because it could lead really, if you stay in direct live mode, you could experience some really bad performance in Tableau. But guess what? Hopefully, our developers have been working on something else, which is called the Alternative Federation Engine, which actually is already released within the product, but it's not, I think it's not 100% ready yet, but we can activate it. I will show it to you in a moment. So the feature goal is to reduce the data movement to the minimum. Let's say we've got 3 data sources, and this SQL table, which contains really a lot of data. The idea here is to, if we're authorized to write data in temporary tables in our database containing our big table, let's do it. Let's put the data there and perform the join locally. Okay. So I've got this data source. I'm going to show you. And so here you go. You got the same 14 million rows of the table, and you've got a user security. So I've put it in an Excel. It's not very secure, but imagine it's in a Postgre database, or I don't know. You see it, my user security. So here's what's happening. It's slow, because Tableau is basically gathering the 14 billion rows locally before. So what I'm going to do is I'm going to just launch another Tableau desktop at the same time. But what I've done in command line is I activated this feature, which I've just shown you. And now we should see a different plan. We're gonna look at the log viewer at the same time, but it should be really faster. So just before that, I'm gonna try to highlight. So you see, Tableau is already computing the layout here, while I think, okay, you already done it here too. It was way faster here. And what I want to show you is I can actually, within Tableau Log Viewer, look at the plan Tableau took. So this is the one without the option. So I can see that Tableau queried the user security table, the orders tables, and get it into Hyper, into FQ temp. If I look at it actually, I will see that this is like federated tables, create regular tables. Here you will see FQ temp 1 into Hyper. While if I have a look at the overlog file, which is actually linked to our other Tableau desktop, if I have a look at the plan, you will see that here I created a temporary table within SQL Server. Way faster. And finally, what's the best to do is, if you can, just do an extract. Here I'm creating. So by the way, I'm computing, if you look here, I'm computing 2 millions .a data point. That's a lot. Using my user security, meaning it's I, as Nicolas, already got access to 2.5 million records over the 14. And as I just said, here I can edit the extract, and now we've got this wonderful option. Multiple tables. Okay? So let's wrap up. What did we learn today? First thing to remember, to take away from here, always consider the design, the calculation, and the query before digging into the data architecture. We've seen you can use index, partitions, column stores, lots of stuff, and mix them together to obtain the best performance. And always think of what you're using in Tableau. Filters, joins. You can use Hyper or the column store for dashboard document accelerations. And there will be changes in the way we generate queries with new data modeling capabilities that have been announced this morning. Okay? So I don't know if the key values on the log files I've shown you will remain the same. I hope so. But still, we can use these tools to to see our queries. And by the way, so I've been asked, we're looking for data models alpha testers. So if you're interested, if you have one of those three, let's say you're in one of those three situations, you have many data sources, you need to blend in a single workbook, you use a lot of LOD expressions to correct your aggregation, to renormalize, or you use scaffolding tables to avoid, to make sure, like this morning, every state appeared, even if there is no data behind. So if you're interested to alpha test this functionality, please reach out to us. Yeah, and especially Ami and Bellany. So maybe I've got like 5 minutes to take questions if you've got, or you have any questions, or yeah, sure. How did I turn on the federation engine? Actually, I just added like these options. Oh, sorry. I can yeah. Sorry, I have to switch. I can show you later on if you want. But I just added this option. Actually, let's debug options. Normally it's for Tableau developers, but we can play a bit with it. It's just to show you there are things that are coming which really will improve the performance. Okay? Any other question? Yes, go ahead.
So if you grow to a data volume size that's getting pretty big, your hyper extracts don't really it's too big for hyper, but then your live performance isn't very good as well. Do you think the next thing to look at might be the platform, like Redshift?
Yeah. So indeed, I haven't talked about MPPs and also cloud databases, which add another approach also. So basically, MPPs will scale out your workload. So they will still give you the options to use column storage, to use partitioned, but it's a great idea to set up a cluster of an MPP, like a Redshift cluster or so, and to use them to query from Tableau. Yet Hyper work very well in scaling up, so it will use all the. So let's say you put it on a machine with hundreds of dozens of cores. Yeah, it will use them. But we don't have the availability to scale out yet. So that could be a good idea. What you've got to keep in mind with MPPs, it's sometimes you need to think about what will be the distribution key of your data within the MPP, and also to use them within Tableau. So that's something else I didn't show, but that you might want to think about. And some cloud databases add another approach. They basically separate the storage and the processing, and they spin up machines on the fly, depending on the money you get. That's it. Have a question? Oh, yeah, 2 questions there. Yeah, you, yeah?
So my understanding of Redshift is that there's not actually the foreign key and primary key relationships don't really exist in columnar databases. Can you still use the new extract features and like a columnar score where there's not those relationships don't?
Yeah, so actually the foreign key and primary key are much more data modeling features, which are not really linked to the physical way data is stored. I don't know about Redshift, so I can't tell, but it shouldn't have any impact on the feature, the hyper feature of having multiple tables. Because it will query that separate. Hyper will query the tables separately, and we will bring them and store them just like this in the extract. You got a question?
Actually, it's not a question, but there's some questions about which stores, Redshift. I've done POCs in both Redshift and Snowflake. Snowflake is, well, okay, both of them, they're think of each column as though they're individual tables. So if you have a billion records, but only 3 unique values in one of the columns, that's exactly what you get. So that's why the performance is so good. Snowflake separates out the warehouse, which is the compute engine, from the storage, and you can provision a warehouse for each individual group of people using it. So one group may completely mess up everything for everybody, but for in their group, but it won't affect, for example, the warehouse for the reporting engine. So you can have people doing all kinds of crazy stuff and joins that just don't work, and you won't know or care. It'll just be their usage. It automatically provisions out both vertically and horizontally, and forest key relationships. You can set them up. They are unfortunately not enforced, but if you want to use them for something like Tableau to be able to figure out how these tables relate, you can do those, and they work very, very well. So I thought I'd just put that out there.
Yeah, sure.
I've been
Thank
using
you.
Snowflake for 3 years now.
Okay.
And the performance has been absolutely jaw-dropping. Between 100 and 1,000 times faster than Oracle or SQL Server under best circumstances. Just put that out there.
Impressive. Thank you.
That's based on how people set it up, right? Yeah, it really depends on what it is you're actually doing. The great thing about Snowflake is you don't have to worry about clustering or partitioning. You don't have to worry about creating indexes. You don't have to create any of that stuff because just the fundamental way it's put together makes it so it's just not necessary.
Well, the reason why I ask is the people that I support, they're using Tableau for next application and work out with the keys that over to Snowflake.
Okay.
So trying to get a sense of whether it's better or not.
Yeah, I mean,
It sounds like between the changes and how Snowflake's done, we'll see enough proof.
Yeah.
One of the really big, beautiful things that we found with putting Tableau into Snowflake was instead of having to do these long-winded extracts that out of Oracle would take hours, we could actually go to the library and make it so you could just have a reply.
Yeah. Yeah, indeed, the approach, everything is based on the fact that you separate storage from compute. And so you can spin up multiple compute clusters with the same storage. That's the way you just, as you just said, business users from finance users will not use the same resources as the, operations or
Like the ETL warehouse.
or the ETL warehouse. Yeah.
Or just reporting warehouse. One of the things we had when we were in Oracle shop is somebody decided to join our site visits for their customers, creating the worst partition product you can think of. They did it on Friday afternoon at 5:30, and then they used the parallel in, so it used up not one of the server processors, but all of them. Yeah, can't do that in Snowflake.
Great. Thank you for sharing. I don't know if we're almost out of time. Just have some related session. If you want to go and see turbocharging Tableau with Hyper, you gotta understand deeper how Hyper works if you're interested in it. And also a session about big data and multiple tier strategies. That could be great. Please, if you like it, complete the survey. It's important for us. Give us your feedback. What did you like? What you didn't like? So we can next year change a bit if you want. Or that's it. Well, merci.